interpreting the consensus ranking based on the weighted Kemeny distance.
Si apre direttamente? Good afternoon. My name is Alessio Baldassarre, and I'm a PhD student in Economics and Business at the University of Cagliari. And today I'm going to present a research titled Detecting and Interpreting the Consensus Ranking based on the weighted Kemeny distance. The research aim is to detect how the use of positional weights could affect the results of a typical preference data analysis. So, in the first part of my presentation, I'll give you a very brief introduction to preference data and some basic related concepts, and then I'll focus on the use of weights and the weighted measures for finding the consensus ranking using a weighted differential evolutionary algorithm. Generally, when dealing with this kind of data, we analyze the preferences expressed by m judges on n items through orderings or rankings. The orderings are list objects from the most preferred to least one, and rankings are numerical vectors that assign a certain rank to each item that goes from 1 to n, where 1 represents the most preferred and n the least one. And there are three main kinds of rankings: full or linear ranking, when a judge expresses his preferences on each item; tied or weak rankings, when we observe the same rank for two or more items; and partial ranking, when a judge expresses his preferences only on a subset of the items. The main goal is finding that ranking that best represents the will of all the judges, and it is the best compromise that summarizes all the available information in a space of dimensions equal to p, as we can see by the equation 1, and the dimension of p increases dramatically as n, so that this research falls within the so-called non-deterministic polynomial time-hard problems. To solve the aggregation problem, there are two main approaches in literature: the ad hoc methods and distance-based methods. And I'll focus on the second one. In 1962, Kemeny and Snell approached the ranking aggregation problem, outlining a set of 4 axioms and determining a distance measure that verifies all these axioms, even in case of ties. As we can see by the equation 4, the Kemeny distance counts the number of interchanges between the pairs of elements required to transform one partial ranking into another, so that the distance between the two rankings A and B of n items could be expressed as follows through a matrix formulation as proposed by Kendall. In fact, this matrix formulation allows to transform one partial ranking into a quadratic score matrix in which the generic elements Aij for the ranking A are equal to 1 if the object I is preferred to J, -1 in the opposite case, and 0 if they are tied or they are equal. So they define the median ranking as that point S in the space of all permutation, Z, that minimizes the sum of distances between itself and all the input rankings. But for this research, we used a weighted approach. So in 2010, Garcia Lapresta and Perez Roman introduced the possibility of weighting discrepancies between the weak rankings. In fact, they demonstrated that the Kemeny distance doesn't consider in which positions there are divergences between the preferences expressed by different judges. So they formulated the weighted Kemeny distance as follows, using a certain permutation methodology indicated with the subscripts sigma 1 and sigma 2. They mean that the orderings B and A are ordered with respect to A and B, respectively. They introduced, of course, a weight vector that is of dimensions equal to n-1, such that the first position has a greater or equal value than the second one, and so on, and such that the sum of all the weights is equal to 1. And they followed the matrix formulation as proposed by Edmond and Mason, in which ties are encoded with the value of 1, which means that the declaration of a tie is seen as a positive statement of agreement and not as indifference. But in many cases, it might be easier to interpret the to interpret the correlation rather than distance, because the correlation coefficient falls within a well-defined range that is -1 and 1. So we use it for the weighted differential evolutionary algorithm, the weighted correlation coefficient proposed by Ploya and others. They followed the same approach proposed by Edmond and Mason for the permutation methodology, and the footsteps of the Kemeny distance, they used the weights to assign the weights to the position of a classification. And the weighted correlation coefficient could be formulated as follows by the equation A7, and where the denominator is equal to the maximum value of the weighted Kemeny distance. This measure verifies the equation that links every correlation coefficient to a certain distance. Recently, D'Ambrosio and others proposed a differential evolutionary algorithm for finding the consensus ranking and solving complex problems, for example, when the number of heights is very high. Here, we modified this algorithm using as a cost function the weighted Kemeny distance. In fact, this algorithm works evolving an initial population of candidates randomly chosen, and then through mutation and crossover operators, the candidates are evolved. In fact, if the new candidate has a lesser cost than the older one, then it will be selected and it will replace the older one in the next generation. The algorithm will converge when it's no longer possible to find a better candidate, so that the best solutions will be all the solutions in the last generation. And we use it as cost functions, the weighted Kemeny distance, so that the solution will be that candidate in the population that minimizes the sum of weighted distances between itself and all the input rankings. And at the same time, it will be that candidate that maximizes some correlations. Here we applied this algorithm to a real data set, and we used 3 different weights vector in order to observe the changes in the results. In the specific, 100 students at the University of Cagliari were asked to order 5 different subjects in relation to the interest, difficulty, and exam preparation time. So we obtained 3 different data sets. Then we evaluated the lambda value, that is the spread parameter of the Mallows model, that represents the concentration or dispersion of all the rankings around the consensus ranking, so that the larger lambda, the stronger the consensus, and if lambda is equal to 0, then every rankings in the universe are equally likely. So we calculated the consensus ranking for each of these 3 data sets, and we introduced the weights vector. W that assigns decreasing weights to each items, W1 that assigns the same value to the first 2 positions and 0 to the others, and W2 that assigned an higher prominence to the first position, 0.8, and 0.2 to the second one. So this is the table of results, and as you can see, for the time data set, we obtained the highest value of lambda that represents an higher concentration around the consensus ranking. We calculated the consensus and the correlation coefficient associated with it that you could observe in brackets. The W counts row represents the results that we obtained using the weight vector that assigns decreasing weights on each items. And as you can see, the results don't change. In fact, assigning decreasing weights to decreasing position doesn't affect the results. Using the W1 as a weight vector, we obtain different results. If you observe the first 2 elements, they change their position for the interest and the difficulty data sets. And looking at the 3rd column, we could observe that the results are very similar from each other. That means that when the lambda value is very high and the number of items decreases, the weight allocation has a lesser impact on the results. So in conclusion, we propose a weighted differential evolutionary algorithm for finding the consensus ranking, and we observed that using a weight allocation, our results could change, but these changes could depend on the weight chosen, the concentration around the consensus ranking, the correlation coefficient associated with the consensus, and the number of items. And obviously, the main limitation of such an approach is that every judge could express his preferences using different weights for different positions. So our next research steps are aimed at reducing this arbitrariness. And that's all. Thank you.
Some question? Okay. I have a question for you, a curiosity. If you come back on the slide number 13, in which you show the results of the toy experiment, if I could remember, the W1 weight are 0.5, 0.500. Okay, so the results, you can show the results now. Okay, W1 counts DACEB. I suppose the interpretation is that the CEB are not important at all because the weight is 0.
Yes, we are concentrating only on the positions that we are weighting. In fact, we could observe a change in the first position, the element, and A changed its position, but we are not observing the other elements because
so
we are
placing a 0 weight to more than one item means don't consider that item in the final solution. Could be a... Okay. Okay, thank you. Another question? Thank you. Okay. Next speaker is Lucio Palazzo, presenting a work named A Malanobis-like distance for cylindrical data.
Thank you. Okay. This is a joint work with Giovanni Porzio and Giuseppe Pandolfo, and we are going to talk you about a new distance studied on cylindrical data. So, in the outline, I will just present you briefly what we mean for cylindrical data, and we also introduce what is a Mardia-Sutton distribution. Then I will present our first result regarding this new distance, Malanobis-like distance, and then finally I will show you the first results that we found. What are cylindrical data? Cylindrical data are just bivariate data where one of the two features is a component is just circular. So we have a direction. We have a direction and a linear feature. What is a direction? What do we mean with direction? We need something that can be regarded as circular data. So some features that can have, let's say, a direction and usually lie on the circumference with the unit radius. We can measure angles in several ways. We have different ways to measure such coordinates, for example, radian, degrees, or polar coordinates. And our goal, our objective today is to introduce this new distance based on Malanobis metric. Why? Because actually we had to take care of the topology of the structure of the data. So data are shaped like a cylinder. So all the points are on the cylindrical surface. So we had to take account about this in order to measure distance within points and don't stop just on the, let's say, simple Euclidean distance. what is the possible application that we can do by using this new distance? We can make clustering and classification, and I will show you at the end of the presentation an example with clustering regarding k-means clustering, or even, for example, outlier detection. The main scientific fields are really, really broad, but let's say the main features can be shown in meteorology. For example, when we want to study wind direction with anything we mind with let's see, with meteorology, like wind speed, temperature, or humidity, or also, for example, percentage of pollutants inside the air. And even wave direction and number or rate or frequency of waves is really important. And if you can see, also the research is very, let's say, is very new regarding such topics. Also, we have environmental analysis, for example. Biology, also in biology, we have like a interesting application regarding cockroach directions. So the researchers are starting to study how cockroaches change direction depending on different stimuli, okay, different electrical stimuli. So they study how, if they can, let's say, direct such animals, such insects, and give them a specific direction based on different, let's say, electrical stimuli. And in order to conclude, color encoding models also is a really nice application, because here is syndical data used in image quantization. What is image quantization? Let's suppose we have a colored image. We want to simplify this image by using just few colors and not all the palette of colors that are included in the first image. So we try to cluster colors in order to have just simpler colors. And what's the nice thing that why we are talking about cylindrical data in this case, because colors can be viewed like directional data plus linear data. For example, the direction is given by the, let's say, the rainbow palette, and the linear data is the quantity of saturation of the white or the black inside the same color, okay? So cylindrical, so distribution, probability distribution defined on the surface of a cylinder are called, of course, cylindrical distribution. And we don't have limits regarding the linear component. It could be unbounded or even bounded. And the circular component usually is a directional variable, of course, and we have to take account of this effect, this difference, and specifically we have to take in account to wraparound effect. So what this means, if we, let's say, turn around how many times, a lot of times, and we stop in the same starting point, the final angle will be the same. So this effect could be taken in account by using specific distribution. And since you are working on a cylindrical surface, could be really misleading to ignore the curvature and the topology of the structure of data. So I will start showing you the Mardia-Sutton distribution in order to explain how we define the Mahalanobis distance, our Mahalanobis distance. Mardia-Sutton cylindrical distribution is the, let's say, the simplest thing, the simplest distribution that reminds us the Gaussian distribution in the bivariate case. In this case, we have the blue part that represents, let's say, the argument regarding the directions, the information regarding the direction of our features, and the red part regards the linear part, the linear component. And in particular, this distribution is defined such that we have this mean and this variance in the linear part in order to have a conditional Gaussian distribution. So good condition to the direction, our distribution will be Gaussian with the specific mean and variance. And also rho, that is the square root of the squares, the sum of squares of the two correlations between the angles and the linear part, can be regarded as a parameter of dependence. So if rho is closer to 0, we have independency. If it's closer to 1, we have that the linear part actually is deterministic. So just to show you some example how works this distribution, I will show what happens where we change parameter settings. In this case, we are fixing everything except for the let's say, the correlation between linear and circular part. So you can notice that this dashed line, this red dashed line is the conditional mean. So actually changing the correlation structure of our data, it just changes the form of the conditional mean. And in order to change also the variance, actually the variability of this conditional mean, we have to fix, in this case, we fix other parameters and we let vary variances. And what happens when we have small variance of the linear component, a high variance of the, let's say, the directional part, we have something that resembles, let's say, a necklace, a bracelet, okay? So we have a lot of variability on the circular part. So what's the goal? The goal is we want to study to fix proper distance measure in these settings, in this framework, and we have to take in account the shape of data. But actually we can use Euclidean distance because we know that we can fold or unfold, let's say, a cylinder and then fold again and have a straight line. The problem is that we have to take in account the fact that a straight line between 2 points, every time we use such data, cannot pass through the cylinder. So we should have something that lies inside the cylinder. So let's say the extension, the natural extension of a line on the cylindrical surface becomes actually an helix. So in order to take into account this effect and also let's say the correlation structure of our data, we decided to use Maranobis distance. Maranobis distance actually corrects, compared with, let's say, Euclidean distance, corrects for correlation between different features. And also, we can provide us different boundaries that are maybe not linear. And this is our proposal, actually. So we start from Mardia-Sutton distribution and define this distance, called the Maranobis-like distance, that actually is part of the sum of 2 parts. Let's say the directional part, this is this one in blue, highlighted in blue, and the linear part highlighted in red. Our first findings are that, of course, we have that the distance is not negative, it's symmetric, and also we have equality between isodistance and isodensity contours. One of first results that we found, one of our first application is we performed k-means by using this distance, this modified distance, that compared with the Euclidean one. First of all, let's compare the contours, the surface contours. What happens? Here happens that the Maranobis distance is able to get the structure of data better than the Euclidean one. Okay, the Euclidean doesn't mind the fact that our data are not necessarily, let's say, Gaussian linear, and we have a conditional mean part here that is well taken if we use, let's say, the part, if you Maranobis distance. And in conclusion, we are going to prove to test our distance by using k-means clustering. What we did, we just applied k-means by using our modified distance. Okay, we plugged in our modified distance, and we find we compare those results with the Euclidean one, with the classical k-means. We have 3 clusters here. We have synthetic data sample. We have 3 clusters. The first cluster is the blue one with squares, highlighted with squares. The second one is the green one, highlighted with triangles. And the final one is the cluster we highlighted with circles. And in each case, we have a different parameter settings. Of course, we change the mean, the linear part of the mean, and the directional mean in 3 cases. And also, we have different variances, different correlation structure in all 3 cases. Our first results are this one. The first plot represents the k-means performed with Euclidean distance, fixing, of course, 3 clusters. And here we can see that we have some misspecification in the, let's say, the borderline parts of the the middle cluster, while let's say in the wider clusters are actually well classified. The main problem is here in the clusters in between. While at the contrary, see, if we compare the results by using the k-means with the Mahalanobis-like distance, this effect is almost completed, replicated, and we can see that we still have some misclassification here. We say that we have some triangles that are still red, they should be green. And on the other side, we have some circles that should be red and actually are green. So we have still some misclassification, but the result sounds promising. And let's say we suppose that we can go further and establish to compare, to represent, or to compare with different methods. So in conclusion, we introduced this new distance, the new distance method, based on the Mahalanobis metric. This distance seems to well capture the structure of our data. Then we applied this distance on k-means clustering, and actually the first results are better than the results that we can get with a simple Euclidean distance. Possible developments, actually we can also extend to other clustering methods, or maybe may have a classification by using this distance, or even consider a robust distance measure by waiting, for example, for let's say outlier points or for far points. Okay, so that's all. Thank you for the attention.
Some question? Please.
Yeah. Actually, geodesic distance is just, let's say, the extension of the straight line on the cylindric surface. Here in the Mahalanobis part distance, where is this, let's say, application of geodesics? Here, in this part, 1 minus cosine theta minus mu0, that is the average, the central point of our distances. In this way, we are taking both in account let's say, the correlation structure of data, because we are, of course, multiplying with the correlation structure, the distance between, by using the correlation structure of data, but also we are considering that instead of having just a straight line, a difference between 2 points in a, let's say, 3D plane, we have to perform a rotation. Okay, so instead of just using the main difference is that here, in the Euclidean case, you don't have 1 minus cosine. So you have something that just every time counts for the straight line. In this case, we are bounding on the cylindrical surface. Okay?
Some other question? Okay, thank you.
Okay, thank you.
Okay, well, the third speaker is Josef Poczeka, talking a talk entitled Euclidean Distance as a Measure of Conformity to Benford's Law in Digital Analysis for Fraud Detection.
Ladies and gentlemen, I would like to say something about Benford's law and application of Benford's law for fraud detection at finance sets of data, and especially I would like to say about Euclidean distance as a tool for testing conformity to Benford's law. the structure of my presentation, of our presentation, because that presentation was prepared by my PhD students and me, is classical: introduction, methods, example, and conclusion. Newcomb in 1881 noticed that there are lower digits appeared more frequently than higher digits in numbers. And the same observation was made by Frank Benford, and since then that is named as Benford law. This is the page of Benford's publication, and you can see how frequently appears as the first digit. Almost nearly 1/3. This is the first significant digit in numbers. For example, if in reverse area, pressure, death rate, and many other examples. And what is the formula for Benford's distribution? The probability of appearing D1 digit on the first significant place is given by the formula and in the figure. You can see that first 2, 3 appeared more frequently than other digits. And we also can ask about appearing first 2 digits. And this is the distribution in case of 2 digits. This is Benford's distribution, or Benford's law, what is known in literature. And there is a question: if every set of numbers is conformed to Benford's law? No, not every set of numbers. And what properties should be fulfilled by the set of numbers? Invariance, according to scale, to base, to arithmetic operations. And there is a problem to check if the set of number under observation is conformed to Benford's law. Mark Nigrini classified tests for Benford's law into 3 categories. Primary Benford's law tests, those are first digit test, first 2-digit test, many others, and advanced and associated Benford law tests. We do not discuss about these tests, only about primary first digit test. And what are typical examples of data sets which ought to be conformed to Benford law? Those examples are like properly carried out accounting data, results of elections, scientometric data, hydrological data, and many other examples. Then is the problem how to test if the set of data is conformed to Benford distribution. and what are examples of application, practical application of Benford's tests. Those typical applications are in accounting fraud detection, and I show the example how this approach could be applied to show what is the chance of fraud, detect fraud in sets of accounting data. And another examples, tax fraud detection in scientific publications, electoral fraud detection, scientometric data regularities, hydrological data regularities. The idea of primary test is to verify whether an empirical distribution of digits in numbers is conformed to Benford law or not. And in this case, we can use many statistical tests as chi-square goodness of fit test, Kolmogorov-Smirnov, Kuiper, and now I show the method based on Euclidean distance. Cho and Gaze propose the measure of checking data conformity to Benford's distribution as follows, as simply Euclidean distance between probability, theoretical probability, and observed relative frequency of digits. In case of, how to normalize this Euclidean distance to D star. And this is the formula for normalizing distance measure in 0,1 for 0,1. Here is the formula how to calculate the distance measure in case of two digits. And similarly, we can normalize it. Morrow introduced the measure based on Euclidean distance as a hypothesis testing the H0 hypothesis. The first significant digit distribution stays in accordance with Benford's distribution. And alternative distribution, empirical distribution of the first digit does not conform to Benford distribution. The statistics is as follows. You can as follows, and in his paper, Morrow gives also critical values for above statistics. In case of two significant digits, the statistics is as follows, and in our environment is enabled to calculate p-value by means of bootstrap technique. And example, we did into account more than 12,000 of foreign revenues from sales in a certain company. And we examined the first two digits, significant digits in this real set of financial data. And we calculate p-value by means of bootstrap technique, assuming 10,000 replicants. Because auditors controlled financial statement of this company accepted this without reservation, we assumed that the sets of financial data are conform to Benford distribution, And this is empirical result. And and what we did, the accountant who did not know Benford's law was asked to commit fraud by adding, only one sentence. This statistics says that this distribution of data set is conformed to Benford law. And accountant at more than 100 falsified records to the data set, and then we calculate the test. And what we see, p-value 0.004, taking into account 0.005, it means that we ought to reject the hypothesis that is Benford distribution. It means that are possible frauds or not existed calculations. Then we test in which classes of values of account operation are special differences between what is really and what it ought to be. And in conclusion, we can say that that introduction of more than 120 falsified records to set A result in decline of level of conformity to Benford laws in case of 5 and 6 digits revenues, because results are different in different scales of values of revenues. And general conclusion is that outcomes of study indicate that technique based on Euclidean distance can be useful as a tool in the process of financial fraud detection as the first step of auditing procedures. And it ought to be more deeply studied statistical side of this test, and it seems to be interesting to compare indications of the Euclidean distance with other possible statistical tests. We did it, and among other tests, test based on Euclidean distance is one of the most interesting approaches. Here are references. Thank you very much for your attention.
We have time just for a question, a small question. Okay, just a curiosity, I'm joking. So in order to avoid to be in jail, we must know the Benford law. So the test cannot detect our fraud.
Yes.
No, I'm joking, of course.
Those are tests defined detailedly by Mark Nigrini, and those are not statistical tests as in the sense of hypothesis testing, but those are procedures how to check what are ideas of check if the set of data would be conformed to Benford's law.
Thank you.
Thank you.
Thank you for the speaker. And,
Close back.
Ci sono i nomi. Dov'è Monica? Monica Brati? Prego.
If you
posso
know how to
farlo?
do-
Ok, sì, sì, sì.
Penso sì. Ma non...
This is
Okay.
what we can
No,
do
just a
later.
minute. We can do it later.
Okay, I do it.
possiamo parlare direttamente dalla...
Stare a sedere. Però non so se si possono spostare le slide.
Ah, dobbiamo chiederlo.
Mi sa che ci toccherà venire qui.
Okay, you can join you can
Ah oui, il faut prendre à mon âge,
Marco non lo capisco. Io comunque ti scrivo prima di dare la
non, c'est une vieille version.
grazie, basta. Se poi non trovi me, perché da varie parti del mondo, Nicola, Salvati, però dico io comunque adesso mettiamo questa rosa e poi perché Elisabetta l'ha fatto in considerazione. Cioè, forse
no, non è il...
À vous qui posez.
Ah, ok, sorry.
Okay, if you have your mail open on your phone, you can send me, I can give you my email, send me the
Yeah,
presentation.
is there the connection? Is there a Wi-Fi? A Wi-Fi?
I think so, just a minute.
Regarde, moi je filme. Par une côte.
No, eri tu là.
Voilà.
In bocca al lupo.
Ça c'est un vrai sujet. Bon. Moi le mien il marche.
So che una voce, però sappi che un budget che è sempre disegnato quindi ci tenevo
Bisogno di togliere la
Okay, just
chiavetta.
check if this is yours, right?
Yeah.
Okay, so this is fine. Okay. We need just her presentation. So,
Pas du tout.
so
Moi ça me va très bien.
bien, on va leur dire des choses. So,
sì, alcune cose sono più tecniche, non più questo là, io peccato non è stato, però interessa
et on te regarde. Okay. Just I put it here. Okay.
Il faut qu'on esprit arrive à gérer les enchaînements. Gérer les enchaînements, c'est ça qui est important dans la logique.
Okay, thank you. start first? Okay. Okay, so... Okay, but for the others there? Okay. Okay.
Il y a une semaine. Mais après, j'ai les vrais pieds de présentation.
If you want even to keep it open, but you can put... Yeah, but we can...
Alors que moi, je suis pas ma langue, je n'ai pas l'habitude de présenter beaucoup en anglais. Donc du coup, ce serait plus une question, je dirais, de langue qui te rajoute un peu plus de boulot.
De complexité dans l'enchaînement des idées.
Oui, parce que tu apprends la langue, enfin la langue.
Oui, c'est arrivé à trouver l'articulation des mots.
Oui, oui. Tu ne trouves pas toujours les 2-3 mots qui sortent tout de suite parce que c'est pas ta langue.
C'est pour ça que moi je fais vraiment de manière comme si je lisais. Je diverge toujours.
C'est tant mieux, c'est la beauté de la présentation. Il y a un petit côté un peu spontané qui est important. Moi, c'est vrai,
Surtout sur les écrans.
Moi, les exemples, je les ai pas préparés. J'ai eu une idée de ce que je...
Sei riuscito a installare?
Sì.
Grazie. Senti, metti qui una lavagna.
Attualmente in uso.
Enfin, j'en parle.
No, volevo prendere la pennetta.
Toi, tu les nommes, tes connaissances.
Magari se lo copi.
Oui.
Solo che l'ho fatto, ma vedi, mi dice così. E allora tiro via. Ok?
Même aujourd'hui, j'ai du mal à... D'accord.
C'est toi qui gères le timing. C'est toi qui gères le timing. Hein, donc c'est comme tu...
Je vois rien du tout. Si de loin, un peu, c'est de près que je...
Okay, I think we can, we are ready to start. So if you can all have a seat, and I think we just received the green light from the organizer, so all the other sessions are over.
Tu parles avant ou après?
Let's go.
C'est après.
So good afternoon and welcome, all of you. I'm extremely honored, but also pleased to have this roundtable, whose objective is, it's a roundtable, so whose objective is mainly to discuss, understand, sharing experience, throwing some challenges on the table, because of course it's a topic, and I'll come to this in a minute, which, for which the answers are being built currently in the world, not only in business, but in the society as a whole. And I have the luck, and I hope you will be convinced by that at the end of the session, to have outstanding panelists. Let me first thank the organizers and the Scientific Program Committee who actually asked to have such an event within this conference. And let me thank personally, but also on your behalf, the speakers, because in spite of the busy agendas, they accepted right away with enthusiasm to intervene in this roundtable. And I'm very pleased they are here with us. I'm very pleased because actually, as you can see, by looking at the program, if you looked at their profiles, and you can see also here it's not a round table, it's a straight table, you see how much diversity we have around this table in terms of experiences, in terms of joining academia and companies, in terms of different profiles, different experiences they will share. So we try to set it up with an objective of bringing to the table complementary views, sometimes not necessarily in agreement, and it's part of the round table. But the whole objective is, as you have seen the title, talking about artificial intelligence and big data. And I would correct part of the title. I wouldn't say in business, because I don't think that nowadays the society can stand any longer silos. I think it's really a societal issue. It's really big data and artificial intelligence in society, including business, but the role that the statisticians and other communities must have must really be towards the society as a whole. Having said that, just a few words of introduction, and then I will ask each panelist to introduce herself or himself. The session, of course, won't be technical, even though in preparing it, we had a sort of private preparation. Quite soon, discussion became a little bit technical, so we won't escape some technical comment. But here, the objective is try to understand in this current revolution, which is quite unique because it's very deep and very, very quick. So I think those are two features of the current industrial revolution: the depth of the impact and the speed by which the impact is taking place. We do have, as statisticians, I feel myself still a statistician in spite of doing quite a different job since a few months, but I think we do have a role to play. You see, many people talk about these topics, but beyond talking, I think it's important to walk the talk, to walk the talk, and when you say walk the talk, understanding a little bit where you are going, who is going where, with whom you are going, and what is the whole purpose of all this. So the objective of these diverse profiles we have around the table is to understand a little bit the impact on business. It's what's happening in a few companies, not only in terms of their strategy, but also an impact on customers. We will talk a lot about customer experience. We'll talk a lot also about customer expectation, but it's also a way to understand a little bit what cultural evolution is somehow undergoing, or what cultural evolution is somehow needed, both in companies and more generally in society. What is the role of statisticians, statistics, organizations of statistics, and more generally in the community? Because we do know that there are some frontiers between our community, because other communities, thinking about machine learning, I'm thinking about engineering, and so forth, so on, that actually do require a deep thought on this. But it's not only a technical or a business or societal issue. It's also issues related to privacy, ethical issues, and moreover, how this is going to have an impact not only in business, but on the population as a whole. So summarizing all these views, this justifies the choice of the panelists, which I think again, and without further doing, we'll give ourselves roughly, let's say, an hour and 20 minutes so that we can catch up the last 10 minutes delay of the day. Maybe I can ask each of the panelists to introduce herself or himself, starting from Jeroen.
Thank you, Vincenzo. So also thank you for organizing this panel roundtable. I think it's really interesting to discuss in front of you, and I hope there will be questions as well. So I'm Jeroen Rombouts. I'm from SEC Business School. I'm a professor in statistics and econometrics. And I'm also involved in the Accenture Strategic Business Analytics Chair, from which Jean-Pierre is the sponsor. He is here today from Accenture. And in that chair, we train 60 students every year to become what we call data translators. That is meaning we want to use our students use advanced data from companies, so internal company data, and work on data valorization. So it's really using techniques of statistics and machine learning to valorize them in businesses. And so monetary value then becomes very important. So apart from that, I also teach big data analytics and econometrics courses, and my research is really oriented into change point modeling and the like. The many discussions that I've seen today in the presentations are very familiar to me, so it's a very interesting conference for me.
Thank you. Thank you, Vincenzo, for the introduction, and thank you for inviting me. I'm very glad to be here. So I'm coming from this area, so I'm a mathematician, statistician originally. I've been working for 17 years on making data valuable with companies, different companies, either in consulting strategy with Bain and finally within Accor in travel and hospitality. So I have been seeing how this data from small to big, how this is creating value for companies, and how technical stack and how technical, in terms of statistics and machine learning, are bringing also this value, and how we can create synergies with people, with academy, to make this artificial intelligence happening and going to the end of the objectives.
Pierre?
Thank you. Happy also to be here. My name is Jean-Pierre Bocopsa. I am running our Accenture digital business outside of North America, which means that I have in my teams many statisticians, data scientists, people able to do e-commerce, and many other things. And I wanted to talk to you about experience, not in the scientific term of it, but more in the customer exchange that people are looking for when they are interfacing with artificial intelligence and with alternate channel rather than physical ones.
Thank you. Monica?
So pleased to be here and honored. I'm here representing the Italian Statistical Society. I'm serving as president now. And I'm a full professor of statistics at the University of Pisa. And my interest is in survey methods, analysis of survey data, and estimation of poverty at local level. Here I will clarify some issues from the perspective of a statistician, and I hope to have many suggestions and many hints from the business world represented here.
So my name is Stefania Rubrichi. I'm a researcher at Orange, that is a mobile network operator that you probably you all know. So I'm a researcher in a lab, in a socioeconomics lab, which is called Sociology and Economics of Network and Services. And I'm more focused on the use of mobile phone data to study human behavior in a way to have a social impact. So I will be happy to share more on that afterwards within this roundtable. Thank you.
Great. Thanks a lot to all of you. So I would suggest to start that we have a first round, roughly 10 minutes, 10 minutes each. So 3/4 of an hour, 50 minutes, so that each of you actually can share specific topics. Then, of course, it will be interactive. So the whole second half, we want to discuss with the audience and challenge whatever has been shared and asking questions and see how do we move forward. So to start with, Jean-Pierre, I can start with you. Based on your more than 30-year experience at Accenture, in spite of your very young age, 33 years at Accenture is quite something, especially nowadays, but you have always been committed to helping organizations transform in the new digital ecosystem, and you have seen a lot of things in different geographies all over the world with a clear objective of using artificial intelligence, big data to make the customer experience outstanding. So can you share your experience with us?
I will try. That's not an easy one, but let me start. You have all heard about the changes we are going in, and today, when you talk about commerce, you see that customer loyalty is becoming more and more volatile, making business very difficult to grow and very elusive in terms of what they want to do. So if brands want to survive in what they are doing, they need to go along with the customers, and they need to make sure that they are very responsive in terms of experience that they provide to their customers. A couple of statistics coming from our research. 52% of Fortune 500 companies have disappeared in the last 19 years. 52%, which is a big number. 32% of customers are looking for personalized experience when they do interaction with the companies. 68% of them would recommend a company with a good experience, which means that for companies, it's very important for them to make sure that what is happening and the way they are interacting with a customer is responsive, is great. And today, customers are more and more connected to the company. They are always looking for an always-on, always-me type of experience, which make it very complex for companies to achieve. And all this is fueled by data and by what we see around customer knowledge and the way technology is able to fuel and to provide broad servicing capabilities. Today, by embracing new artificial intelligence capabilities, we see from natural language processing, from video analytics and video processing, from machine learning, we see companies going beyond the cost reduction to integrate technology, to be part and to integrate technology and insight, intelligent insight to drive a better and a great experience. But what is a great experience and why do we care about AI in doing this? A great experience is an experience that is natural, focused, specialized, predictive, immersive, and beautiful. And that's what we are looking for. And AI has the power to transfer and to transform a regular experience to a great experience. The AI can do this through enabling specialization, enabling personalization at scale, and tuning also individual intention, preference, behavior, to provide very smooth, natural, and intuitive services, but also apply prediction and optimization to run very efficient services when possible. And that's the type of things that we are seeing in the market. So let me give you a couple of examples. I'm going to start with a couple of easy ones that most of you know. When you talk about Spotify, as I'm sure all of you have heard what Spotify is about in music, Spotify is using AI to tailor music to your preference based on what you are listening. When you talk about Kentucky Fried Chicken in the US, they are using video artificial intelligence to predict what you are going to order based on your preference and based on your ability and what you look like. We have been working also with a company named Avianca, which is an airline company in Colombia, which is the second largest in Latin America, the second oldest in the world, to transform the company, leveraging AI and digital technology, from being a pure airlines to become a digital company running airlines and piloting airlines. And this is because those guys were looking for their customer to have a different experience, to feel more comfortable with the way they interact with the company and what was happening. So we have helped them by building a chatbot, a very smart, intelligent one called Carla, that was running the end-to-end journey for the customer. And that's something which has been very interesting for them. And they have rebalanced most of the traffic from their customer service to this chatbot, which is also, in terms of efficiency and productivity, very important. Last example around banking, we have been working with a bank in Thailand where we have created a digital disruptor for them, leveraging AI, and we go beyond banking. When you look at the mobile apps that we have built for them, it doesn't look like a banking app. It's more an app that you can do everything with, what we call a super app. And those have been very interesting because everything is run real time, and you can do mortgage real time, you can do borrowing money, you can pay through the apps without knowing, based on what AIs know about you as a customer. So in Accenture, we are working with a customer, and we try to help them to provide them with a great experience, and that's something we try to do as a living. We work with people, and when we try to have customers going through this, we call those businesses living business. In simple terms, a living business is a business that is adapting itself to to the change in the customer behavior, to the change in the customer interactions, and making sure that we are able to provide them with the right things. And all this is powered by AI that drive data-driven digital marketing at the core to serve and to help customer experience strategies. And that's something which is very important. When you look at this, in theory, when you are pulling insight, millions of customer interactions, you use that as a basis, and then you put machine learning on the top of it and AI to predict ongoing and accurate ongoing and accurate predictions around intent, around preference, around behavior, to provide the best experience for the company you are working with. And that's what we try to achieve with our clients. A couple of other examples in retail, which is an area in business where companies are the most advanced in terms of experience with their customers. And I'm going to use ecosystem experience because you have a huge amount of innovation coming from small startups who are creating a different way of innovating in this way. So I'm sure all of you have heard about Kim Kardashian. If you look at the news, the People news, she is in many of them. And she is also a businesswoman, and she has created an app called Screenshot that uses Instagram photos to properly fit you with her type of clothes. So what she's wearing, you can use that on your leveraging Instagram profile. And you can do it, I think, and then the app proposes you a series of similar fashion that are aligned to what you are looking for and aligned to what you can do, and you can see real time on the app. That's one thing. You have also another very interesting startups, even if it's 6 years old now. It's a $2 billion startup called Stitch Fix, which is a personal stylist providing you with Frankenstein style only based on algorithm driving data that are gathered around the internet. And this aligned to your profile and providing you with the right outfit to be very stylish when you are going out and especially if you are very busy. Last one is one experience that we have done in the cruise business for a company named Carnival Cruise. It's an American company where we have used artificial intelligence to create and to revolutionize guest experience on a cruise, which means that we are able to properly anticipate at every touch point what people are looking for when they are on the boat. Not only we are able to anticipate what they are doing, but also we are able to match all the assets on the boat, meaning the people, meaning all the restaurants and everything you can have on the boat to ensure that everything will be ready for the customer before they are thinking about it. And that's also one of the power of AI, is to be able to match what you want to get and what you have in terms of assets. But AI is not only about experience, it's also about what it can bring for you as an academics in terms of learning, in terms of what you can provide to your students, but also for workers in terms of accelerating the experience when you are working by providing you, when you are maintaining airplanes, for example, providing you with the right change in terms of assets that you can use to replace a piece on an engine, or when you are working in nuclear power, to provide you with the right training to ensure that you won't do the wrong things when you are working on this. Or it can help you as a citizen when you are interacting with administration or you are interacting with hospital to help you to drive a better experience in the hospital. And all of us have been going to hospitals, and we see how poor the experience is when you are going there. And we start working with those guys to ensure that we can provide a beautiful experience. It can be beautiful when you are entering an hospital. One thing we have been also doing, and that's why AI is not only about business, it's also about the way you interact with people. We have done an experiment in Stockholm for elder people, where I think it's called Memory Line, And we, in Stockholm, I think they have an getting older population and people get very lonely. Old people get very lonely. So we have retro-engineer Google Home technology to be able to drive and be, let's call it the AI autobiographer of the people, meaning that people tell their story and the Google Home asks questions about what's next in terms of event in a life. And at the end, we are able to build a podcast showing the full life of the persons, which has created, I think, a very huge interest in terms of how you can leverage technology to help people who can be lonely in what they are doing. So at the end of the day, I really believe that AI can help us as people, as business, can provide, I think, and can help to unlock trap value in what we are doing to create a very different perception in terms of the way the business, where the business is going. And let me finish. You had a quote earlier about Apple. I'm going to use the other one. I'm spending a huge amount of time in China, so we are working with Alibaba as a client. So I'm going to use a quote of Jack Ma, and he said, "We shouldn't be worried about how much AI and the internet are impacting traditional business. Rather than we have to use internet and AI to our advantage. Machine can do what people can't. We must make machine to be our best partner rather than letting them replace us." And at the end of the day, I think machine can be and can help us to drive new things around the world and also help us to create a very nice experience for all of us. Thank you very much.
Thank you, Jean-Pierre. This first view. I have one quick question with a quick answer. In implementing all these solutions and helping digitally transform these companies in different geographies, is there a common challenge that you had to face? What is the biggest challenge you had to face? There are many, but one quick one.
I don't want to be polemic, but the challenge is the people. So it's always very difficult to change a culture in a company because people usually throughout their careers build barriers around what they are doing. And machines have no barriers. And it's always very interesting to see how you can work around this to create a change management program, because here we talk about change management program that will help people to accept technology as a new things to do. And just to give you the example, because you can say that's easy to say you are a consulting firm and you don't know what you are talking about, but we have the particularity to always try on ourselves what we recommend for our clients. We have a very big business process outsourcing business, meaning having people doing recurring tasks in multiple countries, which is representing around 100,000 people. And we have replaced in the last 4 years 20,000 of these 100,000 by AI engines to do a very basic and automated task. And those 20,000 have been positioned on more value-add type of activities and without firing anybody. So it's not easy to do, but at the end of the day, it's possible. And that's one of the challenges we have with technology.
Thank you. We'll have time to come back on this. So Fikra, going back to your experience as a mathematician, statistician, and then going to companies and different ones, you've always been working on helping having data-driven decisions in many companies. Still, we are on customer experience, but now it's more customer expectation from the customers, and now we can let them evolve.
So I think Jean-Pierre, thank you, Jean-Pierre, for the introduction and for the talk about customer experience. I think it's not because it's like a kind of repetition, but you will hear about customer experience everywhere, because today, what is happening today is customer is becoming the center of everything. That's why we will talk about customer experience in all businesses and everywhere. So that's the customer is becoming demanding. He's expecting a kind of unique and unified experience, because he's today in an omnichannel world. So he's when you think about this example of Spotify, for example, if you have multiple devices and you connect to the first one, you have the first recommendation, but if you connect to the second one, you are happy when you find the same recommendation about the music. You see, hey, this Spotify is understanding what I want, and he's knowing me. And of course, this is making your life easier, and this is all about customer experience. So customer experience starts by understanding who are the customers and what do they like, what do they do, and in terms of behavior, what do they want tomorrow, and how is the business in terms of competitions, etc., to understand all of this ecosystem and try to offer the best recommendation or the best service to the customer. That is, because today he is expecting that anyway. So that's why this is becoming the big challenge for businesses and for companies. When we think about customer experience, of course, we think about this customer who is connected everywhere. He's, when we wake up, you are connected. You probably look for, I don't know, the meteo or etc. So you are generating data. When I talk about data, just keep in mind that data is equal also to privacy, of course, by respect to privacy. So those data are generated everywhere. Those are becoming also a big asset for business. They just based on those data, all what is happening today, that we start to generate value, but we will do more tomorrow. So value is not all the time business. It can be health, it can be everything. So that's why this asset should be used by academic, by everybody. I mean, it should be we should be sensitive to those or to this value of those data. But using those data is a challenge for companies, because when you think about data, probably you have your laptop, you just start to download some data, it is big, then you need, of course, how to think about how you will store it. So imagine a company with the millions, that was a bit of my experience with the millions of customers. Those customers, if it's traditional company, they have physical stores or it can be hospitality, hotels, and at the same time, those customers, they have physical experience and digital experience. So imagine those customers, how billions, huge quantity volume of data. And those data, if you think about companies, should be stored by company and should be managed by company to be able and to make them useful and to try to generate this value. So I would say the first starting point of when we think about customer experience is from on company side, on business side, is what are the questions that I need to answer to make my client or my customer life easier. Then those questions, I have to think value. I'm not just running, use cases to use cases. I need to really answer what are my clients expecting. And of course, all those social media, etc., are telling me sometimes what they are expecting. And then I start behind those business questions, that's what we call the use cases. I start to think data. What are the data I need? Do I have the privacy? Do I have everything? And then I start to do I have the platform, the technical platform? And personalization and customer experience cannot happen if we do not have the technical platform behind. That's why the biggest challenge for companies is the investment in those technical platforms, but also talent, because we can probably buy, techniques from Amazon. I'm just saying Amazon because, some from technical, maybe Jean-Pierre, you know more than me on this area, but I can pay Amazon, but if I do not have people within my company sensitive who are really understanding how they will use those data, what is the quality of data, etc., this cannot happen. I can't make it. So technical stack, which is the first layer to start thinking about dynamic customer experience. Centralized data. So this data should be centralized because we need to collect it in real time sometimes. Sometimes it's not in real time. For example, for hospitality, we are collecting some hotels' data every day. So it depends on the business. But those data should be centralized and should be checked in terms of quality, etc. And this is making the first, I would say, stack of data, which is useful. And then we start thinking, because we want to go more far, we want to start to deliver some use cases, which is the first one will be which product I will recommend to my customers. It will be the next best product, for example, for music. Then I will start thinking, okay, which type of data I would like to have. I'm collecting the data, and what type of technical algorithms I can use. Now we need some people who are expert data scientists, statisticians, all those names, because sometimes it's just changing the name, but in reality we need people that are understanding data, understanding math and statistics and computer, of course. So we need those people who will be thinking about algorithm, which type of algorithm we'll be using. And when we will think about algorithm, now the difference when you are in academy, compared to what you are in business, the point is that I can't use any algorithm if it's not easy to industrialize, because one algorithm who will be recommending the best product, even if the precision is the best, it will generate the best value, but when I push it to production, which means I will be making it operational, and if I connect, my client will connect via the application, he will get to the product, then it should run very quickly. Then technically there is a huge challenge for companies, because they are all the time playing between techniques and the advances of techniques, which is really a reality and which is very good, and at the same time between what is really realistic and where they are. And I can tell you that the most of businesses are not really, we can't say that they are on the top of recommendation in real time, etc., etc. So this is a kind of the challenge for businesses. And at the same time, there is something that the business are also challenged with, is the education. I think you talked about education and how to make people using the data in their everyday decision, and just believing or seeing the value of this data when they take any decision. And this is what I'm calling the acculturation. This is something we are not doing it with AI. That's not true. I mean, in business, we need people who are running just simple, regressions, clustering. This is something we do every day, and this is very important to go far if we want to industrialize AI projects. So this is the reality, I would say, of businesses. And in terms of customer experience platform, so I think two very, very, I would say, the first cases that we are, at least I have seen in my experience. The first one is the recommendation engine, which how to recommend the product. Then we start by understanding who are the customers, and who are the customers is also a question of, we start by segmentation, and segmentation, we use all those techniques, of course, not so advanced as what I saw today, but we try to use the most, I would say, sophisticated based on the data. So I don't believe today that a good segmentation is something we can just click, on the button. A good segmentation is something where we will need to see what are the data and what is the algorithm, how to use the algorithm. So successful personalization and successful recommendation engine needs to understand who are the customers, and understanding who are the customers in terms of statistics is clustering them in the best way, which means using in very well and in good technical way algorithms. And then what is happening is the technology after. And of course, some operation research, etc., are here to optimize depending on the context. For example, if we think about dynamic pricing, this is something dynamic pricing which is used by Uber and of course, and sometimes in hospitality, but less, I would say, less dynamic in hospitality. So dynamic pricing is a piece of, I would say, AI today, which is using a lot of data. So data, I will give you an example from hospitality, for example. So dynamic pricing in hospitality is using data from hotels, so from hotels and what we know about customers. And it is also using digital data, understanding the forecast or trying to forecast the demand on the web, so the websites. For example, if tomorrow from Google we know that we will have, 1,000 of demand, then maybe I can, or from this region, then maybe I can push those hotels from this region based on what I understand from the forecast. So that means that we need also some other techniques, which is the forecast. So forecasts, I think, is one of the examples that where we learn or we take an advantage from machine learning, because usually the forecast of demand, which is the forecast of occupation rate or forecast for the demand on the website. So forecast usually is used, or companies were using, very traditional time series techniques. And I think today with the big data and today with all the volume of data that we have from digital and from physical, of course, the forecast is really, we can have a better forecast and more precise forecast by using some machine learning, because we can create a lot of features, and we have also the capacity of computing. So this and the forecast, I would say, of sales, and is the first, the most important input if we think about predictive preference, predictive product, all what you want about predictive. I think there is a forecast there. So this is this area, I would say, within artificial intelligence, I think is calling, I would say, a mix between traditional and novel technology. So I think that this is my experience and my experience hands-on also when I have built teams of data scientists, data engineers, etc. I think it's very important to play with I would say traditional statistics, with knowledge of data, with the knowledge of computer science, and also with different competencies. And I think there is really value and a big value to collaborate more and more. This is my opinion with academic, because there is a lot to do again in artificial intelligence, and this far than it's just a starting point, I can tell you, in terms of real operationalization of this artificial intelligence.
Thanks a lot, Fikra. I have, thanks a lot for sharing multiple aspects of AI projects. I have a quick question for a quick answer. You have seen many AI projects in the company, so you also have seen some of them fail. Yeah. Can you share a bit what, according to you, is the main reason for failure of AI projects?
The first one I have seen, it failed, and it was a big project. It was, this is the point with AI. We should be very careful about, this buzz. You are a statistician, for most of you. I'm a statistician also. Originally, I knew the data. It's like for more than 20 years. And we should be very careful. And what happened in the companies is sometimes they should show that they go to, or they should launch some AI project. And what happened is that they launch a big project without having the data. So without having the data, there was no data node platform. That means that and this is not very rare. I think it's also what I'm saying regarding the platform and the technology. It's also very usual, even in the business. They don't realize how much technology we need to make real artificial intelligence realistic. When we think about those digital platforms, for example, Booking.com, or why they do it? Because they are digital natives. They start with technology, so they go very quickly. But for traditional company, if they want to do this, then they need to invest, and they will not be digital native. That's not true. So they should learn, and they should mix with their, their traditional knowledge, and they should do something with it. So it started without data. They invest a lot. They started with algorithms, and at the end, they just realized that they should invest differently in terms of data. And 3 years after, when you start with this kind of project, there was a lot of startups already. They already did the project, and it stopped. And this is reality, and the millions of investment. So I think the knowledge of the challenge behind AI, real AI projects.
Thank you. We'll come back to this into discussion. Monica, we heard a lot about the vision from the business, their experience, technological, technical challenges to people. Now, what about links between academia and business, and what role we can have in letting statistical literacies evolve, and training and research as well? You have slides,
yes,
so you can...
I have slides.
Yeah, you can go
there.
to the podium. Yeah.
Yeah. Okay. Okay.
Se mi permetti di abituarmi al tuo modo di parlare, posso...
This is an example. Okay, so it should be here. Okay, so the responsibility is very high, and I thank a lot the two previous speakers, because they gave me the opportunity of stressing some aspects I wouldn't have considered so important and relevant. Starting from the last, machine learning and forecasting, I have in mind that maybe this learning from machine and data can be a sort of tautological experience, reproducing the data sets and the data instead the real-life situations of customers, maybe. And this is a question I have in mind while I'm speaking and following your reasoning. So replication of the same reality according to the data set I'm using. Sooner or later, I think that we should go on the field and collect what I am calling real data, not data produced during an experience and data collected without any awareness from the person, from the side of the persons producing the data itself. So this is, I would say, a hidden question, but now revolution is here to stay, and we are not looking to the past. I'm starting commenting data to change. What does it mean, data to change? Let me jump the two slides about the society, who we are, who I am. You know perfectly this. And we have had the occasion of sharing experience with the other panelists. So if you are interested in the society I'm representing here, there is a website and you can explore it. And also here we are hosted by the cladag section of the Italian Statistical Society. Many thanks to this section, very active. It is one of the section, and there are also many other groups in the Society of Statistics. But this revolution opens to challenges to statistical scientific association and to statistics with the capital S, and calls for an evolution of statistical literacy. We will see how, according to our perspective, and this is my contribution to the discussion. I am a professor, so I am interested in how to educate. And this artificial intelligence revolution, machine learning, big data revolution, if you want to call it with these words, is something that is a challenge to me, because I think that we need to educate ourselves and the youngsters in such a way of following all these changes, and in such a way of being, at the end of the day, able to criticize the results and the procedures. Automatism is not what can be used in order to judge the quality of the results. So, data to change means using data to change the world, data-driven innovation. Otherwise, data must be valorized, and they have a value, and they must be used to do something that is useful for the world today. There are many important phenomena on the landscape. Sustainable development goals and globalization. I don't want to enter in it, but we are here for these reasons. But data to change means also that we use data produced using innovative methods. And is it obvious that day by day we are producing data while we are consuming goods, having habits, or expressing our attitudes? These data are called big for dimensions, I would say, and complexity. But to be honest, I don't see clear paradigms for the analysis, clear in such a way to bring benefits to the society and to everyone's life. Obviously, they are the diamond mine of current age. And this is, I think, obvious from what we have just listened. But every datum is a representation of reality, and even when it is numeric, contextual to the event, and immediately available. So we need for data awareness and metadata, and first of all, from a scientific point of view, we need for reproducibility of the data. Because in this, I agree that the goal of the business is different than the goal of the academy, obviously. You have to produce money and to do a service and to have everything here and now in order to obtain a representation of customers, for instance, or a forecasting, or to give an experience to the customer that is natural, focused, specialized, immersive, and beautiful. But it would be an idea to reproduce the data you have had yesterday with the same tools and with the same characteristics and quality tomorrow and the day after tomorrow, because only in such a way they are comparable and we can build a time series and understand from a scientific point of view what is going on. And so it is obvious that we need an evolution of statistical literacy, also because we are not afraid by the big brother or grande fratello, but at the same time we are giving substantial parts of our life, what we call own life, that is a mixture between our real life and virtual life, quoting Luciano Floridi. We are all profiled. We are using the smartphone being here, obviously. And so somebody is knowing that we are here, that we have been in casino, that we have traveled, and all these data are used tomorrow by Accenture or consultant of Accenture to build up our experience as a consumer. When the iPhone was launched, Steve Jobs said that iPhone, you believe you own it, but it will own you. And if you reflect just a little bit on the meaning of this sentence, you must agree. That's true. That's true, but it is not true at the same time, because obviously we are able to be detached from the technology. At the same time we are using, but we are detached in some sense. But together with this, I agree with Claudio Vercellis when he says that algorithm finds correlations that the human eye does not. But as a statistician, I say that saying correlations is not enough. We should say that they are significant, that they are useful to produce a meaning. Not every correlation is good. Pure correlations, they do not give us added value. So from one side, we are in this situation, and it seems that the technologies of the fourth industrial revolution seem expand and increase also our cognitive abilities. Yeah, because obviously we are saying many things more than in the past. But in any case, at the end of the day, there are key questions talking on this profiling of customers, the consumer profiling. We need to describe a consumer categorically so that they can be grouped for marketing and advertising purposes. So we are building on big data, machine learning, statistics, but we are asking also what change are we doing? What are our needs in this process? And which are the solutions? And what about the actors? We need several different competencies and maybe several different actors. And if we look at the competencies behind this, I think that you can agree that the list can be this one in blue. We need analytical thinking, problem solving, creative thinking, but also data collection skills, data quality knowledge, ethics, business knowledge, technology knowledge, and communication skills. So this is why I say that we need to pass from statistical literacy to statistical thinking, including also data awareness and also other key concepts in the art of thinking clearly. There are modern antiques, obviously, we know them very, very well. We do not need to reinvent the wheel. Average, correlation, heterogeneity, variability, sampling variability, selectivity, confounding effect, error propagation, systematic error, and so on. I want to be boring because we need to repeat the words because they have a meaning, okay? Uncertainty, in few words. Uncertainty is here to stay, even if we are producing results using machine learning now, here and now. We must say, we must admit that these results are not certain. They are the result of a process, and in this process, error is present. And if error is present, we have a sort of duty of taking it into consideration and to model it. But statistics needs to become multidisciplinary. It has a multidisciplinary nature, but it should evolve into an overdisciplinary language to extract, transmit, and communicate knowledge. So there is a sort of statistical wisdom, and I invite you to read this handbook by Oates and Heckard, Mind on Statistics. It is important that this statistical wisdom is something shared by the society, because as individuals we learn from our own and other experience, but as a society we learn through scientific studies. We learn to the accumulation of knowledge obtained using data collection, data analysis, and interpretation. And so we have a sort of moral duty because this way of accumulating knowledge must be scientific in some way. Also because the data now are very accessible and the results are very accessible. So we need to go beyond calculation and measures, and we must be aware that nowadays all analytics work begins and ends with a story. So we need to be able to build up and educate young persons able to ask questions and to find out the results using mathematics, thinking in distributions and probability, and then understanding that the statistical analysis is inside the greater machinery of generating scientific knowledge. We need also to renew, and this is something that we must do together with the business world, together with firms, and also the statistical associations will have a role in this, because there is the necessity of communicating that big data are not substituting sources of traditional data in certain statistical fields, that we should make all the effort to make, to repackage the product, the statistical product in some way, and the interpretation we are able to give in a more user-friendly way without compromising the integral quality. And one way is improving professional accreditation processes of non-academic statisticians, because nowadays, if I understand well, in the firms, in the day-by-day activity in business, we need several different competencies and several different professionals, maybe, and they should be able to dialogue each other. Otherwise, we can't go on. We can have the success. And it is important that you have told us that there are success stories, but there are also unsuccess stories, and we build and we learn from them. So there are many good examples. I have listed here some of them, but we are, here to build other good examples. Just to close, I invite all of you to the Festival of Statistics in Treviso on the next weekend, organized together with the National Statistical Institute. And about the future, I would say that we can't be so conservative and old-fashioned as statisticians to say, if my assumptions are not met, we are not able to do anything. This is something that we should stop if we have in mind. But from the other side, it is important that person experts in artificial intelligence, machine learning, are open to admit that uncertainty is here to stay. And this is important from our point of view. So many thanks.
Thank you. Thank you, Monica. A lot of topics that I think will require further discussion. So since I want to move as soon as possible to opening the floor, I move to Jeroen. As an academic, but also holding a chair, so in close connection with companies, what do you think about valorization of these projects by the companies?
Yes, thank you. Yes, indeed. The last three persons have been talking about different topics, and I feel very familiar with all of them. So let me see what I still can say after these three contributions. So I wanted to give two concrete examples of data valorization in companies. One, a large company, mature, and a digital native company, more startup, very recently started. But before that, what I see more generally also by working and collaborating with other companies is that this digitalization, and the examples were there from Jean-Pierre and Fikria, is giving very interesting data. And so really new types of data. And what I mean by new types of data is what you see is mixed. I wrote it down because it's mixed frequency, and it's often geospatial, and it's unbalanced panels. Okay, and they come from e-commerce, but also from other types of applications. That is from this side, but also you have, if you look more at bigger companies, you have industrial applications that give also balanced panel data, but they are very high frequency, like Internet of Things, sensors. They monitor characteristics of an industrial plant, but they can also monitor your heart rate or something else. And these give very interesting data that I didn't see today. I mean, I was here today listening to the contributions of the sessions on mixture modeling and non-parametric mixtures, Dirichlet prior processes that I also work with. So these are the applications that I've seen today or the models that I've seen today are very, very interesting. I think they could really be useful for this type of data. And of course, there's a mismatch. Like on the one hand, you see very solid technology, you improve methodology, and you can show that it works in simulated settings, and also artificial data, and also in applications. But these applications are often not very recent and not applied to the recent technology. And the reason I'm saying that is that not for advancement of science you need to have the most fresh data, but at least in econometrics, and if you think about, for example, the field of financial econometrics, there by looking at all the data and learning about the stylized facts of these data, you create new models or new features of models that you would like to develop. And something, I think, this feedback that you learn from the data is interesting also for science. So in that sense, I think that as researchers, from that side, I'm definitely a researcher. I think it's very important that we can learn and use the data that is coming from this digitalization. And that is of course complicated because we talked about reproducibility, just the previous speaker. Well, this is complicated because the data, since data is becoming the key assets of the company, it's very difficult to give it to a researcher and then let you work with it. So there is this issue of regularization, but also privacy issues, and since it's a very valuable asset for the company, it's difficult to work with this type of data. But I think it's crucial for also developing new models from a theoretical viewpoint that we have these new types of data in front of us. And I think in the future we should, of course, we are here at a conference, academic conference, we are all professors, most of us, so we like our job, but I think it's, we should be maybe thinking about getting more in touch with companies on a more frequent basis and learn what type of data that is used there to learn about the models that you are developing. So I think these two can go together. So the applications, and now I come to these two concrete cases. The applications that I've seen at about like 10, 15 companies over the last 2 years, you still see a lot of descriptive and data visualization. So since there's a lot of data at hand, companies, they know have all this data. It's very granular data. So data visualization with dashboards, just computing means and producing data on maps is still very important, and is very used in all types of layers of the enterprise. So I think it's so at that stage it's very standard. It's descriptive statistics, it's visualization, but it's very important because since you have these tons of data already from there without any model, you can do non-parametrics, which is descriptive statistics. You can learn about a lot of things without modeling. So, of course, but this is a FICREA point of predictive analytics and forecasting. This is not something you can do with data visualization, of course. And there you see attempts to do standard analysis, time series forecasting, basic ARIMA type of models or multivariate pharma models, which were invented by Box and Jenkins in the 50s by engineers, I think. So these are all techniques, but you still see them very often applied. So the dynamics of time series is modeled by standard techniques from ARIMA modeling. Multivariate, univariate, and not the more advanced things that we see here, like the mixtures with any potential infinite number of components that you don't see, to my experience in private business, although I think they could be really interesting applications there. So let me, and so recommendation applications that we talked about are also something that we see. And then if there is some high-end machine learning, I've seen it in multiple companies, but it is almost always at the proof of concept stage. So there's no, like you said, scaling it up to something really that is usable, apart from chatbots and recommendation, very simple things. I didn't see them really already used at these companies. So two examples. One is a more mature company, is Fnac Darty. I don't know if you know Fnac Darty. It's the French leader in retail home appliances and electronics. So they sell washing machines, dryers. And what we worked on was the problem of, so this, if you buy an appliance, your appliance can, like a washing machine, can go, there can be some issue with this washing machine, and then you need to call the repairs department, and then the problem is that often when a technician comes to your home, that the equipment that he needs to solve the problem is not in his car, and so you need this second intervention, and that costs a lot of money to the company. It's millions of euros per year. This second intervention, I'm not talking just by an intervention, the second intervention, just because the technician didn't have the pieces necessary to repair. This is a lot of money, and it's also in this Fnac Darty, one of its key selling points is that they really go for the after-sales service, customer satisfaction. Well, you can imagine if your washing machine is broke and you have a technician coming and the piece is not available or it's not in his car, you're going to be very angry. And so customer satisfaction goes down. So it has a long-term impact also on the company from that side. So what we did is we used the last 15 years of text data from all the technicians in France, and every time they do an intervention, they write down in text what is the problem, what piece was missing. Sometimes there's no piece missing, because I saw that 67% of the problems are solved just by manipulation of the technician, because of course, if you buy a washing machine, no one ever reads the user guide. So then you get a problem, and then the technician helps it without putting another piece. So these 15 years of data, we have product references, the departments in France, the after-sales service center address, levels of technician by his degree, and the years of experience, so we can see if the technician is very experienced or not. And then we used all this data to do a very simple dashboard, so that the technician can and RT can see where are the problems happening at which time. And for a bit further analysis in terms of technicity was a regression analysis, where that was just to explain the probability of having a defect product and which pieces are required to solve the broken system. So in that, just by doing that, by being aware where are the problems happening for which machines, we had this predictive tool, and it is solved by our students. It is not something I did myself, it's the Accenture chair. My students did that, and so they solved this type of issue, and they can gain 2 million euros per year. Okay, so there again, in companies, they don't think in statistical loss functions, they think in monetary loss functions, and here the loss function is 2 million, the result is 2 million euro reduction. And also, of course, something very interesting is, thanks to the use of their data, it's not only being cost effective, they also developed a new service which is called an SAV barometer, which allows to study for all these products that are sold at this retailer, what is the lifetime of this product, and then you can make rankings, which brand in the company on the website is having a good product or not, and customers can learn about, if you buy a washing machine, do you want to buy a Miele or want to have some other brand, what is the lifetime of this product, and if there is a defect, what type of defect is there. So all this type of analysis, just simple descriptive statistics, but creates a lot of value to the company, not only from cost effectiveness, but also from new services point of view. So that is one example. If I still have time, or you would like me, yeah, we can go.
Yeah,
okay,
thank you.
Thanks.
Thanks a lot, Jeroen, for your sharing. Stefania, last but not least, social impact, because we heard a lot about technology, value, money, experience, but in a world that is really more and more technological, technical, industrial revolution, there is still a social impact, social issues. So how do we put human beings at the middle of all this? So you can share with us your experience at Orange.
Yeah, sure. So thank you very much for this kind invitation. So as Vincenzo said, I'm going to focus more on the use of big data for social good, and I will show you a bit on how mobile network operators are using mobile data to make more responsible business. So, as you know, in the last decades, there has been an explosion of data. Data produced more or less passively as a byproduct of our interaction with technologies, and so with the mobile phone too. So this data, as they have already said during this roundtable, are transforming the way customers are conceived, but and also customer experience. But at the same time, the scientific community, together with public and private agencies, NGOs, and governments, have wondered whether it is possible to use this data to have an impact on the society and to create opportunity for the developments for the international developments, let's say. So in 2015, the United Nations have adopted the 2030 Agenda of Sustainable Development with 17 goals that that address the needs of ending all form of poverty, to tackling climate change, and more in general to improve the welfare of population all over the world. And they called for a data revolution as an enabler of such goals, as a means for monitoring the progress of these programs during the time. The mobile industry is also through what we call the GSMA, which is the International Association of Mobile Operators. They committed also for maximizing the impact of mobile phone data for the social goods, and they have established the Mobile for Development Partnership, where the mobile operators work together with the global agency and NGO to make this data, mobile phone data, available easily and in a secure way, of course. So Orange Group, Orange International Group has also supported this cause, and through different initiatives, the two more important are the D4D challenge, that are data for development challenges, that are open innovation challenges that have been launched in Ivory Coast, the first one, and in Senegal, the second one, where the mobile operators have opened the mobile phone data to the scientific community, and so scientists were called for promoting research and project for improving the welfare, for supporting the development and improving the welfare of a population in these two countries. Why mobile phone data? First of all, because the mobile phone is a very pervasive technology. Here you have some number, so it very pervasive, let's say, at a global level, even in low and middle income areas and over all socioeconomic spectra. They provide us with an alternative and very powerful source of data that can be used as a proxy for other information. Just to give you an idea of what mobile phone data are data that are collected for billing reasons, by the mobile phone operators, and so every time you make a call or send an SMS, records is collected, and it contains very detailed information about the communication events. Let's say we don't have any information about the content of the conversation and the SMS, but we know, for example, the identifier of the two parties, some information about the timestamp, and most importantly also the location of the antenna which is handling the communication. So this data could be used, as I said, as a proxy for location and mobility information, because we know the location of the antenna which is handling the communication, so we have an approximation of the location of the user. We can also use this data as a proxy of social interaction, so social networks, who is calling who, when, at which frequency, and more in general, they are a very good proxy for human behavior. There have been three main use cases that have been identified in the fields of mobile phone data for social good. So the first one is the global development, that is the use of mobile phone data in the fields for addressing, let's say, more long-term social issues. For example, mobile phone data have been used to support electrification planning in Senegal, or to support also transportation planning. That was a project from the first D4D, so in Ivory Coast. The second category is mobile phone data for official statistics. So mobile phone data could be used to predict and to infer some statistical indicators like poverty rate, literacy rate, population density. So we have many projects in collaboration with the National Agency of Statistics in Senegal and in France too. And finally, mobile phone data for humanitarian action and crisis responses. So mobile phone data could be used to not predict, but maybe prevent and address and deal with crises like epidemic spreading, for example. Because we know that the mobility is, human mobility is one of the main factors that impact the diffusion of an epidemic, so the spatial diffusion of the epidemic. So we can use mobile phone data to integrate this kind of information in more traditional epidemics models, and so we can have a better description of the epidemics for better address the epidemic itself. So very powerful data, but at the same time very sensitive. So we don't have to forget that we are dealing with personal data, and so they are very sensitive data, and if they are abused, they can put in danger the security and the lives of people. That is why Orange has also launched another cooperative project, which is called the Opal Project, where Opal stands for Open Algorithms, and the idea is to bring the algorithms to the data. So the data will stay within the premises of the data provider, and the idea is to develop a platform that will run behind the firewall of the data provider. That could be not only a mobile phone operator, but also a bank or other companies. And so by doing so, we don't have anymore the risk related to the transfer of data, and at the same time, we are going to provide the platform with what we call the bank of algorithms, that are a set of algorithms previously approved by an ethical, scientific, and governmental committee. So, here there is a reference to the website of the project, so if you are interested in more details, please don't hesitate. And yeah, I think I will end with these slides, and I thank you for the attention. Thank you. Thanks a lot, Stefania.
I think you touched a very relevant, sensitive, and touchy subject, because, as I like to say, we have been given the technological user guide of this object, but we have not been given the social user guide, so we somehow most often suffer from, we are imposed a lifestyle from this object rather than trying to use it for our own lifestyle. So I think we have touched quite a few topics, different aspects, so also some provocative comments. So without further ado, I think we should open the discussion, spend 20 minutes on this. And the discussion for me is also between the panelists, in case panelists have questions on other panelists' intervention, do not hesitate, and from the audience. So I would give the presence to the audience if there is any comment, remark, question, challenge, provocation. You are mostly welcomed. Yes, please, Daniel. Who starts? Everyone should.
Regarding the first question, I think that today is, I mean, at least in Europe, we are really, we are very, very careful with the privacy. So when we talk about, it's very nice, of course, to talk about those platforms, this customer experience, industrialized customer experience. But of course, one of the challenges is we can sometimes, for some area, for some use cases, we do not have the data because we do not have the validity from, or we do not have we need absolutely to have the client accepting if we want to use his data or not. So in my usage, we never use data from clients or emails to send any message if the client did not sign for it. So I think, especially now with GDPR, all companies, they are very, I think they are very careful with this. The second question, and maybe if you have something to say, is the second question is regarding the environment. I think that the companies are creating a kind of environment to push or to create, of course, profitability. That's normal. But I think what is impacting the customer is not only this environment created by company, is all what is happening, because today the customer is exchanging also with peers. He's discussing over, you know, social media, and this is having impact. And the measure of this impact is not very easy. The companies are trying to understand, to include it into their models to create this perfect experience and to create this perfect product. But we do not have, of course, that's also a question of data we are not collecting, and of privacy. We can't go through Facebook and collect the whole data, for example. That's one point. And those kind of, and it's very complex. I don't think it's just a kind of environment created by company. It's the whole ecosystem around the customer, and this is also the challenge of this huge data and this huge revolution of what's happening today.
Okay, so this is for me the most complex topic, and you missed one element, which is responsibility. If you take autonomous vehicle, for example, what happens if an accident occurs? Who is responsible? Is it the car, the manufacturer, the engine? So, and that's a very complex dilemma for people, and that's what is slowing down what technology could do today. And because we need to think, we need to sit, and people have started try to reflect and think about what they should be doing. There is no clear answer yet, but this is coming, and when things will be properly assessed, everything will be ready for a huge disruption in what we are doing.
So yeah, thank you for your question. This is a very big issue, and yeah, for my experience, I think that what I said before, Opal, the Opal project goes in this direction. So the idea is that no one will have access to the raw data, so to the individual data about the single person, and we are going to share just the aggregate data using algorithms that have been approved by an ethical committee and a scientific one.
Thank you. Any other? Okay, from your side, someone. No. Okay, yeah, we are getting to the end of the session. Any further specific comment?
Monica left. Monica already left.
Sorry?
Monica left, or is she coming back?
No, she had to leave because she's catching a train.
Okay.
So
no, because but I think in terms of research, she was saying that we should be able to reproduce. But on the other hand, in the research, what I see from the data is that there's a lot of non-stationarities. in the application. So it's kind of impossible to reproduce things because the systems and all this data that's generated is evolving in an unstable way. So the things that I've been seeing in the change point analysis today in the papers, I think this is really interesting as applications, because you cannot think that this data is growing and is coming from one data generating process. It's coming from something that is unstable, and the fact that it's unstable has to be modeled itself. And therefore we need to take into account and figure out what do we mean by a representative sample to estimate models. Because more data is not necessarily coming from the same system. So you need to watch out when you do research, when you develop techniques, that this non-stationarity itself is taken into account. That's something that I'm particularly interested in myself.
Good, thank you. Any other? I would just, as a word of conclusion, well, first of all, for your contribution, many things have been shared. I think sharing experience from people from different backgrounds is extremely important, because there are many issues which are not all technical or technological, as we might read in some cases. They are also ethical, privacy. I think there is a question of values, where value is not only money value, but it's really a question of values, and we all have a responsibility of training our students and doing research, which is not only related to providing technical solutions, but there are values behind that we need to defend. I think this is extremely important, and which shows that we cannot work any longer in silos, and multidisciplinarity is extremely important, because from each disciplines and each background we can actually provide a contribution to this revolution, which is there. So it's not a matter of hiding or avoiding it, it's there. So it's a matter of rather influencing the impact rather than suffering from the impact that will not manage. So we gave our contribution today, but of course the discussion is open, and I think we can have it during the cocktail and the concert tonight. And thanks a lot for being here.
Figure this out, I guess. Put it in here. Okay, maybe get your help. Yeah. Way down the bottom. Sorry. Oh, there it is, yeah.
Ah, okay, the first
Yeah,
one.
top one.
Okay.
that you went here. Thank you so much.
Oh, I'm happy to be here. See a lot of people I haven't seen already.
I will attend your lecture and then go to another session. Maybe too much.
We're supposed to have a little coffee break now. I don't know if it's this time or not.
I suppose we were almost consuming our coffee.
I need the coffee.
You need a coffee. Do you want a coffee? I will bring it for you.
You don't mind? Okay. Cody latte? Cody latte, sì, grazie. So how do you do full screen? Show me how to do that.
Okay.
Full screen.
List, then modalità schermo intero.
Okay, all
I
right.
will do it when you will do it. Don't worry.
Okay, all right. Okay, grazie, grazie. All right.
La banque mondiale, les indices, etc. Pour expliquer, enfin pour essayer de faire. Et moi j'ai vraiment réussi à faire des petites lectures en une semaine, mais grâce à des données qui sont un peu finalement faites pour ça. Ouais, et pourtant ça marche. Ouais, ouais. Ouais. Non, c'est une fois par an, mais même ça aide. Oui, oui, bien sûr. Tu as des documentations là-dessus? Oui. Le mieux, c'est que je te l'envoie. Parce qu'en fait, le mail, il est changé, celui qui est utilisé. Je te renvoie mon mail.
Ho fatto un po' di foto.
Così mettiamo.
Dopo delle non sai cosa soddisfatto?
Sì.
C'è stato un sacco di gente a sentire. Sì, parecchia gente, sì, però fa parte del gioco.
Tu me dis si c'est bon. Exactement. Ça. Mais j'ai écrit quelque chose comme ça.
Excellent, oui, oui.
Tu lis.
Pas de battre.
Ben, tu me dis si tu aimes.
Oui, oui, très bien. Avec Guillaume de
Je l'ai fait en Et puis, je lui ai demandé de. Vous êtes dans l'email.
Oui, il est bien. Là, il y a pause. Ah ouais, je vais prendre.
Il faut élargir.
Bon,
Tu verras la main. Ouais. Il faut qu'on fasse une photo tout à l'heure. Oui. délégation.
Capito? Io ci arrivassi pure io.